And I'd like to talk a little bit about the implementation that Orbitz has done with Couchbase, how we got started, what we were looking for, and what we've been able to achieve. So first, I'd like to talk about the scalability that we discovered. First of all, in some of our past solutions that we were looking at and what we had quite a few nodes, a lot more nodes than we would care to have, and hardware costs, electricity, HVAC, et cetera. So we found that Couchbase was a number one solution out of everything that we tried because of the size that we were able to create these clusters at. Additionally, the deployment speed. It's much faster to deploy on these Couchbase clusters than any other solution that we were able to find. Configuration requirements, there's quite a few less, a lot less time, a lot less resources. And the scaling method, how are we going to scale this, vertically or horizontally? What are our options? And we like them best with Couchbase. So first, I'd like to get in a little bit more with the cluster size. We currently have 2 data centers. The way that we were deploying our previous solution, we had clusters set up that spanned both data centers with a 40 gigabit link between both data centers. At capacity levels at the time, we were able to achieve what we needed to, but our capacity needed to increase. So with that increase, we also needed to have a scalable product. What we were using was just not fitting the need. We then have a second, each one is divided into points of sale. So we have a second point of sale with yet another cluster, same size, basically separated between US, European Union, and then we have a third point of sale that was much smaller for Asia Pacific. There we go. So what we were able to do then is to remove all of those boxes and create a new Couchbase cluster using 6 boxes in each data center with 1 replica set that is 1 cluster. Unfortunately, you'll not be able to control which box the replicas go to, but with that high speed between the 2 data centers, we're able to actually have somewhat of a good DR strategy and recover most of the data if one data center goes down. If you can see here, this is currently with 180, upgraded, I believe, actually to 181 this week or later last week. So we're already seeing a lot of the increases in speed for rebalancing. We started the beta test on 2.0 on Monday. One of the teams involved will be working with this particular unnamed cluster that will reduce the size of this cluster by probably another 2 boxes, be able to set 4, maybe 5 boxes in each data center with full bidirectional replication. So that this way, if we have a data center go down, we don't have to worry about a disaster. We have most of the data, if not all of it, already replicated every time there's a change. Now, the deployment speed was another factor that we were looking at. Our previous cache took weeks of planning. We had to figure out what were the changes in our network topology that might have occurred since the last time we did any kind of change. How many nodes are we adding? What kind of changes to the data that we're retrieving has happened? Then it took hours of testing this in pre-production to make sure that we have everything right. Now, I don't know about your environments, but ours is you can never fully replicate a production environment in pre-prod testing. There's all sorts of variables that are different. So we also had to implement hours of downtime in order to actually achieve these changes. So we'd have to wait for monthly maintenances to go in and take the sites down, dust them with a maintenance page, and then implement our changes and cross our fingers that nothing was going to happen when we brought everything back up and started taking traffic. With Couchbase, it's days of planning. We only have hours of testing and pre-production because we can expect the same results. There's very few variables in the way Couchbase is performing in our pre-production environment than it is in our production environment because it's the exact same type of data, the same keys, not necessarily the same values and maybe not the same throughput, but we can expect the same behavior. And then it's just minutes to deploy without any downtime. This was the only choice that we had out of all of our options that was able to provide all of this for us. So then configuration requirements. So looking at our previous cache provider, we had to deal with memory partitioning. How is it going to affect? Every time we had to add capacity, we had to add nodes. Every time there's more nodes added, we had to repartition the memory and how it was working. We had to take our VLANs into consideration. How does that cluster product handle different VLANs based on where the nodes are? What are the number of nodes? What are the communication settings? Do we have to worry about buffering on the network? Do we have to worry about different speeds from different switches throughout the network? The communication settings were probably the biggest problem that we had. And multicast configuration versus unicast was also a big point that we had reconfiguration issues with. And then the node membership. I don't know, how many other products other people have been testing or have used or are still using, but the number of nodes is a strong selling point here. When you're able to reduce 60 nodes down to 10, the cost savings alone, the power savings, the management, as well as the resources required in manpower just to handle all of those boxes, the savings is astronomical. So looking at Couchbase on the other side, the laundry list is a lot smaller. It's simpler planning formulas to be able to decide how many nodes we have to have, how the memory is going to be used, creating the bucket, point and click, type in a new name, work with the developers to make sure that they know exactly how they're going to be using that bucket, set up replication, then add the node, deploy, and rebalance. All of this without having to consider whether or not we're going to take the network down, whether or not our customers are going to be able to continue buying our product. So then the scaling methodology, horizontal versus vertical. It's a matter of use in this particular case. We do have some caches that are out there that we'd rather horizontally scale, others that are perfectly fine vertically. It all has to do with the hardware that you're using. We've had a massive upgrade in our hardware based on what we used to use, but our current use is blade technology, 96 gigs of RAM or more, 300 or 600 gig hard drives, we get 10 gigabit network throughput just within the data center. It really depends on what you're using the cluster for at this point. Then talking about the reliability, we're able to distribute our nodes throughout the entire data center. This way, if we have a rack that goes down, a switch that's providing network connectivity to that rack goes down, half of the data center loses connectivity for whatever or loses power, our nodes are distributed throughout that data center. It doesn't matter what VLAN they're on, doesn't matter what subnet they're on, it's all transparent to our cluster. Failovers, the same thing. The nodes are transparent even across our data centers because we have that high-speed link. The cluster just knows that it's a node that went down. It could have been in the same chassis, it could be across town, could be across the country. So all of this bundled into the networking, we don't have as many considerations that we have to deal with networking. So we don't have to get the time from our network team to try and figure out what's going on with configurations. We don't have to worry about what they're planning. If they're doing a change to network topology or doing DNS changes, doesn't matter to us, especially with the ability to go in and change in Couchbase so that it doesn't use IP addresses, it uses DNS names for the hosts. You can change my IP address. I don't care. The cluster doesn't care. It's going to resolve through DNS. The nodes stay in the cluster, and the customers keep getting served their data. So continuing on that point, Couchbase, again, doesn't care about our VLANs, our subnets, doesn't care about our chassis, doesn't care about our data center, whereas the previous solutions have. So looking at failover, using one of our search caches as an example here. Customer comes in, does a search. We've built a currently still called a Membase session manager to be renamed Couchbase session managers shortly. Excuse me. Comes in and does a search, and it hits both clusters at the same time. This is a particular setup where we have mirrored cluster in both data centers, getting the exact same data. So they do the search, they check to see if the data is in memory. We have this set up to where all of the data is actually stays resident in memory. We don't pull anything from disk on these particular searches. It's just the way we want this one set up. And if the data is not in cache, it'll actually go back to the back-end database and pull the data, populates it into the cluster, and then we're able to, whichever cluster returns the information first is the one that the application gets. So it's a way for us to actually keep both clusters balanced. Sort of our own implementation of cross-data center replication before 2.0 came out. We've been doing this actually since version 1.7.1. So this is going to be probably one of our first options to, once we're done beta testing 2.0, to try and move into that same model with this particular cluster. It will actually save us the back-end calls to the database, which can be quite expensive depending on how much information you have to pull. So looking at performance, we've been actually able to increase performance on all of our caches that we've deployed so far in the respective latency. I'll show some graphs in a little bit that actually show what has happened from the actual point of switching over between two different caches. And the other performance point was being able to keep things resident in memory as opposed to having to deal with pulling things off a disk all the time. The uptime and availability, I'll get into that as well, and Couchbase versus relational database management systems, or any other SQL, MySQL, Oracle, whatever database that you might be using for backend. So for latency, this particular graph comes from an in-house product called Graphite, which is open source. We're able to actually use the REST API for Couchbase, grab all the statistics and store them so that we can pull up graphs at any time. On the left side, you will see what our latency was. This was average latency improvements from the old product. And from the moment that we switched to the cache and restarted the applications on Couchbase, it's quite drastic. We went down on an average of 25 to 47% as far as the latency is concerned, which is quite a drastic improvement. If you get 5%, it's usually pretty good for most cases. Then our max latency improvements, again here, you're looking at an average of 1,000 milliseconds. With the old product, as soon as we turned on the new product with Couchbase, again, the latency bottoms out. We're just not having the same problems. It was averaging, I believe at this case, somewhere around 47 to 52 milliseconds for latency. For in-memory, this is using another previous cache as an example. We were storing on the old system 600 gigabytes of data that was being served with a 30-minute timeout, or time to live on the objects, using much more RAM in the cluster, using many more nodes in that cluster. We reduced the cluster size by, I believe, 125%, somewhere right around there, and dropped down to using 50 gigs of memory. And this is still keeping those sessions live in memory and serving out with the increased latency, or the increased times and lower latency. Now, availability, giving 3 more examples of caches that we have from the slide that you saw during the opening presentation that Frank had used of ours. These caches, or these numbers, are based in red of the old availability. Now, this is a combination of downtime for maintenance, for any time that we had to take everything offline and dust our site in order to make changes, as well as issues that arose after we brought things back online, and we'd start to have nodes drop out. We'd have timeout issues with non-responsive calls to the cache. As soon as we installed Couchbase on all of these, we went to 100% availability. We may have incidents that arise that are just driven by nodes having issues, which is generally a hardware problem, or we've had bad RAM in a node from new hardware that we ordered, or needed a firmware update. The problems were never with the cache, it was always some sort of hardware issue that we've been having lately. Take the node out, put in a new one, rebalance, customer doesn't know the difference, operations doesn't know the difference other than the fact that all the red lines in their monitoring system have gone away and turned green, and they're happy campers, they can close a ticket. When you're looking at back-end databases, we now have fewer connections, fewer databases and tables that are required, especially for new caches. People want to start using the product where they were thinking about using some sort of SQL solution or a back-end database. Now they can actually create a Couchbase bucket. They do a little bit of planning with us, we deploy it for them, and they've got exactly what they need. We don't have to worry about the costs of bandwidth and indexing and queries and getting a hold of DBAs to help with any kind of changes. In a world where you've got global support on your systems and systems throughout the world and customers throughout the world, it takes a lot of time to get the right people together. So it's not just the cost of making the calls to the back end, it's also the cost of the resources, the people, and the planning and so forth. And we've been able to cut all of that time down. One of our other points in researching and deploying the Couchbase as a product and solution for quite a few of our needs was the manageability. Migration and sizing of clusters, integration via the REST API, the ability to gain metrics and insight into what the product is doing, as well as the resources required to actually deploy it. Under migration, moving things between clusters is just something that was unheard of, at least not without a lot of pain. Older products and a lot of other newer products that are out there require downtime, or they require a lot of reconfiguration. We're able to actually just on the fly move things to a different cluster if we need to. Using an mbean in our Java application, we can throw in an override, use the mbean to reset the client, and now it's talking to a completely different cluster. Consolidation, we've been able to take a lot of old systems and combine them into one large common cluster. With non-mission critical things, if something happens, we can easily rebuild that information, but we don't need separate clusters and separate systems and separate environments set up for these 5 to 10 or whatever number of current clients that we have connected to that cluster. Shared hardware, right there, again, we're saving on having to deploy multiple instances. On-the-fly resizing, it's not something that you could do with a lot of other products or our past product. We couldn't just say, the developers want to add a couple new fields to the data store. They want to add 3 new keys, or they want to increase the size of the document. Took a lot of planning. You had to get the DBAs involved. You had to plan schema changes. You had to plan reindexing. You had to plan downtime quite often. Now, somebody wants to change it, it's on the fly. They just change what they need to change. And then they just deploy it at will. It's a great new concept, push button deployments and changes without having to have all these people involved with new applications and new features that you want to put into your website. The integration part has been actually very good for our developers. With the downside of only having one administrative login currently, most administrators, I believe, especially me and my team, do not like giving out a password to a production system to anybody except for the people who have to manage it. And it also does not make good sense for change management to be able to allow people to just go in and have full rights and administrative access to change whatever they want. But using the REST API, we've been able to collect all the data that people want to see in the console and create scripts that actually pull that information, place it exactly how we want, and then throw it into any other third-party application. Or if they want, they can just log into the box, run it in a shell script, gather what they want, grep for whatever data. But as I had shown earlier, we have the Graphite product that we're able to throw that into through Streambase and store that information as well for later lookup. This is an example of one of the Graphite maps that in our hotel rate cluster, you can see where We had one cluster in green, another one in purplish blue color that had been down, and we're able to actually track the progress of what happened when that data started getting repopulated into the secondary cluster. So we can keep an eye, or allow our developers to keep an eye on what's going on with their cluster without actually giving them that administrative access into the console. So looking at resources that are required for, as I touched on before, schema changes, the geolocation of staff. A lot of our database administrators are off-site. Some are in India. Big time difference. So getting these people together to do a change, it's not easy. And then the replication tools and what's available to make sure that our data is replicated and available for recovery in case of a disaster. Or in many cases, people like to replicate the data from production into a staging environment so they can look at real-time data instead of having to generate fake information. So in summary, the product is scalable for us. It fits all of the needs that we were looking for in quite a few areas where we were wanting to change what we were doing. It's reliable and it performs awesome. It's probably the biggest the biggest change that we've made in the last year or so to producing a lower latent and faster product for our customers. I know for me personally, if I go to a website and something takes more than 5 or 10 seconds to display on the screen, I move on. And in this instance, cache produces more cache. I know, bad joke. It didn't go over that well when I did the similar presentation for my bosses, but whatever. The manageability of the product is also one of the big things. I have a rather small team, but it's a team of overachievers who like to dig into everything and do whatever they can and find nice, new, groovy products to add to our site and to our list of tools and set of functionality that we provide to our internal customers. The ability to manage this product so easily and seamlessly gives us the time to investigate all the other things that we need, investigate how we're going to move forward with the next version of 2.0. So looking ahead, we're looking to do a lot more conversions. We still have a few upgrades to do. We're actually still running a couple of 1.7.1 clusters, non-critical. So we're moving them as we can get to it. Most everything is already up to 1.8.1. We're looking at more consolidations. What other caches do we currently have, or things that are still running on things like cache or memcached that might want to be moved into the Couchbase arena? We can look into those. We have time for it. Database augmentation. What that means to us is, again, with the high cost to making calls to the back-end database, what is it like to actually place Couchbase in front of that, use some other application, whether written in-house or third-party, to make calls from the database during off hours and repopulate the cache. We actually do something similar with NFS file system on one of our content clusters, where we actually pull the information from NFS and store it into a Couchbase cluster so that we don't have to make those expensive calls to disk. And then with Couchbase 2.0, as I had mentioned earlier, we're really, really happy about the data center replication. The reason for this is with a major DR strategy of making sure that everything is fully recoverable, that we can serve our sites out of any data center at any given time, which also means reducing the number of times we have to dust for maintenance. If we can switch between data centers seamlessly and easily so that our customers don't know, or maybe there's a little bit of a blip depending on the application and the requirements, we can still keep our sites up and keep on serving our customers and making money. That's what the bottom line is for anybody, I think. Then we possibly might be able to augment our indexing applications, things like Solar or any other indexing products that are out there. Maybe they don't need the full suite of functions that something like Solar gives them. Maybe that can be pulled into Couchbase. and the reduced mapping for analytics. I know I would really love to see the top 10 searches that were made at between 5 and 10 p.m. on a weekday, so we can see what people are doing, where they want to go. It gives us insight into our customers and what their choices are, and be able to take that information, save it somewhere, and refer back to it at later times. And then metrics integration. As you'd seen with Graphite, we're able to take that information, store it offline, and refer to it for as long as we want to keep that data. And another product, App Dynamics, that we're currently using, gives us insight into our entire stack. And now with the ability to turn on an HTTP listener on the client installed on our Couchbase nodes, we're able to use the REST API, collect all the statistics that we want from Couchbase, and throw them into App Dynamics. So we can actually see real-time usage of the cluster and see the calls that are being made between our applications and the Couchbase cluster, the milliseconds it's taking to be returned. We can even decide to dig deeper into that information and actually see the data that's being returned, see the key values and the document IDs and so forth that are being returned back to the application. Gives us a deeper dive into not only how the application is performing, but if we're seeing problems, if we're having some sort of latency issue or application functionality. People are always first to blame the network. Sometimes it might not be the network. It might be a bug that was introduced in a latest release, and something might not be getting referred to properly in the cache. So we're going to be able to see that. So, does anybody have any questions? We have, I believe at the last count, about 17 clusters, running about 250 million objects, about a little over 1.5 terabytes of memory in use. Most of the clusters we're running fully resident in memory. We do, of course, do replicas, but again, in our line of business, we like to make sure that the customers get the information as quickly as they do. We've maybe done a little bit of overkill with the way that we've sized our clusters and the hardware that we've thrown at them, but the hardware we're using is a standard that we're using for everything, and it just happens to be a very good fit for the clusters, so we're able to reduce, in some cases, like I mentioned earlier, from 60 nodes down to 10. That's quite a difference. Granted, the old hardware was a lot different. You go from 2 cores to 24 cores, and 8 gigs of RAM to 92 or 96. It's a big difference. But again, it's based on, as Perry was saying previously in the last track, that you have to deploy, you have to monitor, see how it's performing, and make your tweaks, make your changes, and decide how it's working. So that's also how we've been able to decide how many clusters that we wanted to put out there. And some people want to say, make one big cluster and throw everything in it. That may work in some cases, and it certainly doesn't work in our cases. We've been able to combine some, but not others. Yes. No, everything is, he had asked if anything was in clouds, if it was all dedicated hardware. We do not use cloud computing at Orbitz. We have everything in-house. So these are all dedicated clusters, but again, they are distributed both not only within the data center themselves, but they're distributed across 2 data centers. We do have some that are virtual. Most of the virtual boxes, though, are used in pre-production and staging. Anyone else? Properties as referring to what kind of property? I can be a little general. For the most part, I'd say at least 50% of what's coming up on the page, if somebody goes to Orbitz.com, is a mixture of cache and the use of Akamai or CDN. But again, some of the information that's also going to the CDN goes to the CDN from cache as well. Might be a little bit overkill, but the CDN is a backup to our backup. Yeah. Okay, well then if there's no other questions, I will be up in the lounge if anybody wants to come up and speak to me in further about what we're doing at Orbitz and what we're looking at doing in the future. Thank you.